If there is life on Mars, it may already know we are looking. Humanity has sent more than 10 rovers and landers to the Red Planet. Many have gone silent, malfunctioned, or disappeared under circumstances that were never fully explained. Coincidence? Perhaps. Or perhaps something does not want to be found. Scientists once discovered a chemical compound in Martian soil that on Earth has only one known source, the metabolic byproduct of living organisms. The finding was announced, and then, quietly, it disappeared from scientific discussion. Let's start with what Mars used to be. Today, Mars is a desert world. The atmosphere is razor thin, air pressure just 1% of Earth's. The average surface temperature is minus 60 degrees Celsius. Ultraviolet radiation strikes the ground with nothing to stop it. Nothing we know of could survive on the surface today. But 3.5 billion years ago, Mars was an entirely different world. It had a thick atmosphere. It had liquid water. Rivers carved channels across its surface. Lakes filled craters. Some regions may have held shallow seas. Scientists have found river delta formations, sedimentary rock layers, and ancient lake beds across the Martian surface. All of it is evidence that liquid water existed there for extended periods of time. And on Earth, wherever there is liquid water, there is almost always life. Mars once had everything life needs. So did life ever appear? In 1976, the Viking landers conducted an experiment on the Martian surface called the Labeled Release Experiment. The principle was straightforward. Inject radioactive carbon-tagged nutrients into Martian soil. If microorganisms are present, they will consume the nutrients and release carbon dioxide carrying the radioactive tag. The instruments will detect it. The soil responded. It released gas. The pattern of that release closely matched what you would expect from microbial metabolism on Earth. The lead scientist Gilbert Levin believed he had detected life. NASA's official conclusion was different. The soil, they said, contains highly oxidizing compounds such as peroxides. These reacted chemically with the nutrients and mimicked the signature of biological activity. The chemical explanation is scientifically valid. But Levin maintained until his death that a pure chemical reaction could not fully account for the data. The debate ran for 40 years. It has never been fully resolved. The deeper problem is this. Under certain conditions, the signals produced by chemical reactions and microbial metabolism are nearly indistinguishable. Our instruments may simply not be sensitive enough to tell the difference. Then there is the methane problem. Methane in the Martian atmosphere is extremely unstable. Ultraviolet radiation breaks it down within a few hundred years. If methane is detectable in the atmosphere today, something must be producing it continuously right now. NASA's Curiosity rover detected methane in Gale Crater. The concentration varied with the seasons, rising in summer and falling in winter. That seasonal pattern is exactly what you would expect from a biological or geological source cycling with temperature. But the European Space Agency's Trace Gas Orbiter, a more sensitive instrument, looked for methane at the same time and found nothing. 2 spacecraft, same planet, opposite results. That contradiction has never been explained. On Earth, the 2 main sources of continuous methane production are geological activity, specifically a process called serpentinization, where rock reacts with water, and microbial life, particularly methane-producing microorganisms. Mars has far less geological activity than Earth, but serpentinization can still occur slowly at low temperatures. Neither explanation has been ruled out. Neither has been confirmed. In 2021, the Perseverance rover drilled into sedimentary rock at Jezero Crater, a location confirmed to have once held a lake. It found complex organic molecules. Organic molecules are the fundamental building blocks of carbon-based life, but they do not require life to form. Meteorite impacts and ultraviolet radiation interacting with rock surfaces can also produce organic chemistry. Finding them means Mars has the raw materials for life. It does not prove life was ever there. The rock cores Perseverance collected are sealed and waiting. The earliest they could be returned to Earth for analysis is the 2030s. The real answer may already be sitting in those tubes. But the surface is not the only place to look. The Martian surface is hostile beyond almost any environment on Earth. But underground is different. Below the surface, rock shields against ultraviolet radiation. Temperatures are more stable, pressure is higher, and liquid water becomes far more plausible. In 2018, the European Space Agency's Mars Express spacecraft used radar to scan beneath the southern polar ice cap. At roughly 1.5 kilometers depth, it detected a zone of unusually high radar reflectivity. Some scientists interpreted this as a subglacial lake of liquid water. Subsequent studies proposed the signal could instead be caused by specific types of volcanic rock or clay layers. The debate remains open. If the liquid water interpretation is correct, the water would likely be extremely salty. Salt dramatically lowers the freezing point of water, keeping it liquid even at temperatures well below zero. Under the ice sheets of Antarctica on Earth, similar brine lakes exist, and those lakes contain microbial life. Whether Mars has something equivalent under its poles, no current technology can verify directly. Taken individually, none of these findings prove anything. The 1976 experiment has a chemical explanation. The methane readings are contradicted by another instrument. The organic molecules could have non-biological origins. The possible subglacial lake might be rock, but place them together and they form a pattern. Mars once had liquid water. It may still have liquid water underground. Its atmosphere contains methane of unknown origin. Its soil contains complex organic chemistry. And a 40-year-old experiment still has not been fully explained away. Collectively, these lines of evidence point toward a real possibility that life once existed on Mars, or that some form of microbial life is still holding on deep underground in conditions so extreme that we have not yet been able to reach it. This is not science fiction. This is the question that some of the world's most serious planetary scientists are actively working to answer. The answer may already be on its way back to Earth, sealed inside a few grams of Martian rock, waiting. Until that day, no one can give you a definitive answer about life on Mars. But science has never advanced through certainty. It advances through generations of people who refuse to stop asking the questions that do not yet have answers.